Hello everyone, my name is Shoykot Shoaib Ahmed, a student at SZE Ispaniguidam. Today I'll be presenting Project Task 2 for the Technical and Economic Fundamentals of Vehicle Development course. This evaluation focuses specifically on the engine and powertrain systems of a passenger vehicle, conducting in collaboration with the department standards set by Audi Hungary. For the assessment, I have selected this black Audi Sedan. As we can see from the exterior view, the vehicle is being inspected on level ground to ensure accurate fluid reading and mechanical symmetry. The goal of this specific report is to move beyond the bodywork and dive into the heart of the machine, assessing its current health, identifying potential maintenance needs, and ensuring its overall reliability for future operation. We begin with the identification phase. To ensure this vehicle matches its official documentation, I am cross-referencing the data plate and registration documentation to confirm the VIN and gearbox code. This particular model features a B60 propulsion system delivering 220 kilowatts and 580 Newton meter of torque. I have performed an initial visual inspection of the engine bay, checking for general cleanliness and ensuring there are no loose connectors or obviously disconnected components that could interfere with our technical testing. Moving to the fluid assessment, we are checking the critical system for both volume and health. I have inspected the coolant expansion tank, engine oil levels, and the power steering pump to ensure they are within manufacturer specification. Beyond simple levels, we are performing safety tests, specifically measuring the water content and boiling point of the brake fluid to detect any signs of contamination. Additionally, I'm verifying the freezing point protection for both the engine coolant and the windshield washer fluid to ensure the vehicle is prepared for all operating environments. Next, we focus on the mechanical integrity of the powertrain. This involves a detailed examination of all belt drives, pulleys, and crankshaft vibration dampers for signs of wear or improper tension. I'm paying close attention to the timing belt where accessible, as this is a critical maintenance item. I have also performed a visual walkthrough of all cooling and hydraulic hoses, checking the reserves for any signs of cracks, leaks, or fluid seepage that could lead to system failure. Finally, I have inspected the main fuse box and relay panel to ensure all electrical connections are secure and free from corrosion. A vital part of our assessment is the cold start process. Immediately upon ignition, we are listening for specific noise emissions such as the sound of hydraulic lifters, belt squeals, or chain tensioner irregularities. During this initial warm-up phase, I am also monitoring the exhaust composition for any excessive soot formation or unusual water vapor. This observation allows us to verify that the cold start enrichment system and the idle speed stabilization are operating correctly, which is a key indicator of the engine's internal health. Now we move to a critical dynamic test, the clutch efficiency assessment. To perform this safely, I have ensured the handbrake is fully engaged in a clear, open area. With the engine running, I select 4th gear and increase the engine speed to between 2000 and 4000 RPM. Upon releasing the clutch pedal quickly, the engine must stall immediately to confirm the clutch is healthy. If the engine were to continue running, it would indicate a on clutch requiring replacement. However, this test is used sparingly due to the high load it process on the powertrain. During the road test, we shift our focus to the drivetrain's behavior under load. I'm monitoring for any unusual hesitation or noise during gear changes and listening for the pronounced humming of a differential, which often signals lubrication issues. I'm also verifying that the driver shaft operates smoothly without shaking or vibration. Finally, I'm checking for clicking noise during cornering, as this is a primary indicator of on constant velocity joints, while also noting the integrity of the operative rubber boots. To elevate the professional value of this report, I'm utilizing several specialized auxiliary tools. An industrial stethoscope is used to pinpoint internal engine or bearing noise that are not audible to the naked eye. For safety, an infrared thermometer allows me to measure the temperature of cooling hoses without physical contact. I'm also employing a UV lamp to detect potential fluid leaks via UV dye and electrical measuring instruments for precise diagnostics of the battery and alternator output. Lastly, an endoscope is used for a detailed inspection of hard-to-reach areas within the engine bay. To conclude, this detailed inspection provides a holistic and professionally grounded view of the Audi sedan's engine and powertrain condition. By systematically evaluating every aspect from official identification and fluid quality to mechanical integrity and dynamic road performance, we have completed a thorough technical assessment. The vehicle's current operational health is now fully documented, providing a solid data-driven foundation for both long-term maintenance, planning, and informed purchase decisions. This concludes my presentation for Project Task 2. Thank you for your professional attention.